Okay, another video, quick video, I hope. Uh, Quadratic function, we talked about it the last time. Excuse me. And I just want to review. I mean, in chapter 9 we looked at linear functions, and now we're looking at quadratic functions. And so I guess the question might be, what's the difference between a linear function and a quadratic function? Well, linear, you see the word line in there. When you do a linear function, you're just graphing a line. The line is a straight line. You can draw it with a ruler. Pretty easy to do if you needed to draw it out. A quadratic, and that's like a linear line right there shown. A quadratic function, when you have to graph it, again, quadratic functions you graph, quadratic equations you solve. I guess that's true for linear as well. As I mentioned before, a quadratic function being graphed is going to be squiggly, and so it's for the most part going to look like a U, or it's going to look like a smile, depending on how you want to see the world. So that's it's going to have that sort of U shape, and if you remember from the last lesson, we call that shape a parabola. It's called the parabola. So now, just want to back up a little bit and talk about this particular parabola, because this is the one that they call this the parent parabola, and there are children parabolas that are, basically going to sort of resemble this. But they call it the parent parabola because it's sort of the shape that you kind of use as a reference point. So you're always saying, well, how does another parabola compare to this parent parabola? And the parent parabola is, if you write it out, it's x equals y squared. X equals y squared. Now, in the, when you're dealing with a rather simple parabola, remember from before, we said something about quadratic equations. The quadratic equation is in the form of, and I'll put it here, quadratic equation is in the form of what? Well, we can say y equals ax squared plus bx plus c, or we can say f of x equals ax squared plus bx plus c. It's the same thing. Sometimes you'll see it as y, sometimes you'll see it as fx. The only thing is a cannot equal 0. Okay, a cannot equal 0. B and c can equal 0. So if you look up here, this parent parabola quadratic function has y equals x squared. Well, that's just saying, in this case, we're basically saying a equals 1, b equals 0, and c equals 0. And that's how we get that. So if we had to graph this out, I kind of did it ahead of time to save time. If I were to graph it out, and when you're graphing parabolas, you do it in a table form, at least initially. And when you do it in a table form, you want to start with some negative numbers. You don't want to choose huge negative numbers because you don't know what you're going to end up with. So you always want to maybe stay somewhere, close to 0. -3. Sometimes I might go out to -4. Depends on what I'm doing. But you're just trying to get an idea of the shape. You're not going to be exact unless you're using a computer, but you want to just get an idea of what the shape would look like. So an idea is this, so this helps to give me an idea. If x is -3, and this is our equation, y equals x squared. If x is -3, then y is 9. If x is -2, y is 4. If x is -1, y is 1. If x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 4. If x is 3, y is 9. Now what you'll notice is, notice here, y is 0. This is kind of marked as when x is 0, y is 0. That's right here. That would be like the vertex. Used that term in the last video. This would be vertex. Okay, so what it's saying here is if x were -3, -1, -2, -3, y would be 9. And that shoots way up here based on that scale. And when x is, notice when x is +3, y is also 9. So at 1, 2, 3, y is also 9. And this, once you have those 3 points, you can pretty much graph this equation. Hope I did that right. Anyway, it should be, it's like up here, wherever 9 is. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm sorry, it's right here. Okay. All right. Once you have those, you can pretty much graph it. But just to sort of add some more, if you had graphing paper, it would really help because you can add a little more detail. So when x is -2, it's going to be, you get 4, and it's the same thing as when it's +2. So if it's -1, -2, 1, 2, 3, 4, that's this point. And if it's +2, 1, 2, 3, 4, that's that point. And then you just kind of draw it. It's not a hard, fast V, so it's a quadratic, so it's going to have a curve to it. So when you draw it out, you always want to draw it as like have a little bit of a curve to it. So that's the parent equation. Now, one of the things that you'll notice, and I'm just going to tell it to you, but you should discover this on your own, or you'll discover this eventually. When you have an equation written, and it's written in this form, you can tell something about the parabola just by the numbers or the coefficients that are being used. So, real quickly, if the A, we know it can't be 0. If the A is positive, your parabola is going to look like this. If the A is negative, if that's a negative A, it's going to look like this. Okay, so that A tells you a whole lot. In our parent one, the A is a 1. Okay, so everything sort of compares to, or gets referenced back to the parent parabola. So now, if A is positive, again, it's a smile. If it's a negative, this is when A is a positive, and this is when A is negative. Okay, I know this moving video is tough, but I don't have a camera to, hold this phone. I don't have a stand to hold the phone. So, what if A is greater than 1? In our case here, x squared, it just has a 1 in front of it. Well, what if A is greater than 1? If A is greater than 1, you're going to have a real steep parabola. If A is less than 1, meaning if A is a fraction, you're going to have a wider parabola. Okay? You'll go through and you'll notice that in some examples. Okay? So the more examples you do, the more you'll sort of notice that based on what A is. So if I gave you an example of, I need you to graph y equals negative 1 over 4x squared, I can immediately say, okay, B is 0, C is 0, I'm not worried about that. I can immediately say, well, it's negative, so I know it's going to go like this. and it's a, it says fraction, so it's probably going to be somewhat slim. It's going to be somewhat slim. What if I said, what if I, instead of just saying y equals x squared, what if I said plus 8? And we're going to actually graph that. Well, I know it would go like this normally, right? Because it's negative, so it's going to be upside down. And it's a quarter, so it's going to be slim. But what about that 8, that positive 8? That is represented by the c in our equation, a x squared plus bx plus c. So if you look at whatever that c value is, that'll tell you how high up or how far down you're supposed to go on the y-axis. This being the y-axis. It would be nice if I could spell. Anyway, AXIS. So because it's 8, I move this up 8. 1, 2, 3, 4, 5, 6, 7, 8. So technically, this wouldn't be here. 1, 2, 3, 4, 5, 6. It would go here. If this were negative 8, then this line wouldn't look like this. Negative 1, 2, 3, 4, 5, 6, 7, 8. It would look like this. I'm sorry. Because it's really bad. Because it's a negative A, it's the upside down frown. Or, upside down smile. Anyway, it would look like that. Okay, this looks really weird. Anyway, that's been 12 minutes. All right.